Okay, so I think we'll get started. Hi, everyone. This is quite the gathering. This is awesome. All coming out for the food in the back. I mean, for Maddy's thesis defense. So yeah, hi, everyone. We've got, I think, like 40 people on Zoom or so. So for those who don't know me, 56. Wow, it was 40 like 2 minutes ago. So for those who don't know me, I'm Crystal Ng, and I'm a faculty here in the Department of Earth Environmental Sciences. I am one of Maddy's advisors, and Mike Dockry there from Forest Resources Department is Maddy's other co-advisor, and I am really, really happy to welcome you to Maddy Nyblade's PhD thesis defense. So just as a bit of background, Maddy joined us just a little bit over 4 years ago, and at that time, we're really just getting started in building this tribal university collaborative around interdisciplinary research on Manoomin or Psiη or wild rice. And I have to say, Maddy, that today it's actually really emotional to be here where you're at the conclusion, at least, of this part of your journey, because during this time, Maddy has played such an integral role in bringing our collaborative project to where it is today. And, you know, I think you can see by all the people who've shown up here that I think for a lot of our tribal partners on the project, when they hear about our collaborative project, they actually probably, a lot of them think of Maddy before they think of any of the faculty leads on the project. And yeah, and that's just been, it's really just been incredible. She's definitely been a huge part of, I think, the engine that just has moved the work forward on the project. But I'd say even more important than that, she's really been a lot of the heart and soul of this project. And I think it's really responsible for bringing together so many of our tribal partners, researchers, and students on the project here. And yeah, obviously, Maddy will be the one explaining our project, but I do really want to emphasize that it's really not a standard research project. We're really trying to do things differently so that we're truly working in a holistic and collaborative way to do work that supports tribal sovereignty and tribal communities. And I can't emphasize enough how thankful I am that we've had Maddy helping us, and I'd actually say really leading us in doing a lot of this. You know, I think that it's definitely, as she's going to demonstrate, her tremendous analytical and intellectual talents that have allowed her to do this really complex data analysis to address tribal partners' questions and concerns. But you know, I think what really makes Maddy special, though, is just her incredible ability to actually completely reimagine how science is being done. And it's more than that. I think it's really her passion and actually just getting through any obstacles to make sure that that happens. And I think, you know, there's a lot of you here who are involved in our collaborative project. A lot of you are from our department. And so I think you know that her efforts really extend to work that she's done in this department as well, in influencing us and really leading us and doing a lot of justice related work. And I know I've seen you really doing so much to bring together graduate students, your fellow graduate students, and supporting them. And I've got to say personally, Maddy has definitely done a lot to push and challenge me. And I want to take this opportunity to thank you, Maddy, for doing that, because it's really taught me a lot. And so clearly she has done so much. And so obviously it's really hard to be letting her go and leave us. But she has a new faculty position waiting for her at SUNY's College of Environmental Science and Forestry, where the right there, she's already advertising, where the search committee chair, Robin Wall-Kimmerer, was definitely very wise to see all that Maddy has to offer when she was interviewing just 3.5 years into her PhD. And so, okay, so obviously it's really hard to be letting Maddy go, but I guess the way I need to do that is to shut up and stop talking about how much Maddy means to the project and to me, so that she can actually get on her way of giving her presentation, so that you all can see just how much she's learned and how much she has been teaching everyone around her. So here you go, Maddy.
Thank you, Crystal. Well, thank you all who decided to spend your afternoon with me. Thank you for your time, and folks on Zoom too. I'm really grateful for the time that you're sharing with me, and I'm hopefully repaying a little bit of that with some food in the back. And so apologies for folks on Zoom, but hopefully you can eat Manoomin, Psiη, or wild rice in the near future. So I'll get started. So first, I want to, the title of my project is First We Must Consider Manoomin, Psiη, Impacts of Climate and Land Cover Change on Wild Rice. Manoomin is the Ojibwe word for wild rice, Psiĩ is the Dakota word. And I want to first acknowledge that we are on Dakota homelands. And while this project most closely works with Ojibwe nations, we are also working to build relationships with Dakota communities. And you can see some of that work through this presentation, but know that there's a lot more work to be done, and we are still learning how to do that. I am a settler. I grew up in central Pennsylvania on Susquehannock land, and I come from descendants of Europeans who've come at a various number of times throughout US history. And so I bring with me a worldview of the Western dominant or mainstream culture, as well as really grounded in mainstream or Western science. And I'm excited to be here today to share with you all that I've learned and share the gifts that have been shared with me, as well as invite you to help me continue to grow on my journey by asking questions and engaging. And feel free to reach out for folks on Zoom afterwards if you have more questions. I also want to acknowledge that this is a work of a team. There are so many people who have supported me, who've guided me, who've taught me, and contributed directly to this work. This is a photo from 2022 of many partners and collaborators and students, but not everybody. It is incredibly hard to get a group photo of us because we're a big team and not everybody can make everything. But this is the most recent, most accurate one, but it's missing new students that joined this year, and you all have been important to this work as well. So to walk you through the outline of my presentation, I'm going to simultaneously walk you through the life stages of Manoomin or Psiĩ. I'm going to use the words Manoomin and Psiĩ together when referring to Manoomin Psiĩ as a whole. If I'm referring to wild rice specifically with regards to work I've done with Ojibwe nations, I'll use Manoomin. Specifically with regards to Dakota nations, I'll use Psiĩ. So hopefully don't get confused, but bear with me on this. And I probably will mix it up. Okay, so we begin with seeds, and I see seeds as connected to values. These are the gifts that our ancestors have given us, guides of how we should live and move forward, just as seeds carry those instructions for how the next generation can live. And so I'll walk through the background of a project that builds towards the values that we hold. Then we put these values into action, and they grow and sprout, grow roots through relationships. And so I'll talk about how we built relationships on this project. And with relationships of trust and respect, we're able to share different ways of knowing. So I work with tribal nations. I bring a Western or mainstream worldview, and I have the privilege of working with folks who hold indigenous worldviews or walk in many worlds. And so finding ways to share and create a common understanding, as well as reflect back and learn more about our own ways of knowing. And this is a big piece of the word, so I had two little figures there. Then we move into questions. When we are able to share our understandings, we've come up collaboratively with research questions. So these questions center tribal priorities, and they shape the rest of the work. I'm relating this to the floating leaf stage of Manoomin Psiĩ. So this is a stage around June when the seedling has grown up to the surface of the water and the leaf is resting on the surface. And this is a particularly vulnerable and important time for Manoomin Psiĩ. And I think the questions we ask in research are also a very particular and important point of any research process. And who gets to decide what questions are asked is incredibly important for how the research continues. And so is my goal through this work to have centered tribal nations and their priorities in these questions, just as this life stage is so central and important for how the health of Manoomin continues throughout the year. Then I will share about my methods. I'm relating this to the flowering and seed growth stage. Flowering because we're sharing different ways of creating knowledge, so cross-pollination to lean into that metaphor of different ways of knowing. as well as we're creating knowledge, we're creating new seeds and growing them in this stage. And then I'll share with you my results. And I see these as the seeds and how we've harvested them. But importantly, results straight out of models are pretty hard to digest. And just like you cannot start eating Manoomin right after you harvest it, there's an extensive series of steps to process it. Just as with our data and results, it took a lot to understand them, understand the limitations, and a lot of iteration between all of our knowledge systems and all that we had to offer each other. And so I will be sharing that with you. And then we'll start to wrap things up with celebration, with feasting. And I see this moment here as a piece of this, as sharing Manoomin Psiį with you that I harvested this year, as well as celebrating the work of tribal resource managers, tribal nations, and other resource managers across the Upper Great Lakes region who've been doing the work on the ground to protect and restore Manoomin Psiĩ. And then Manoomin seeds rest over the winter. And so importantly, after this presentation, I will also rest. But also, this is a place of reflection and thinking back about the time. And so I'll end with sharing some reflections with you and some key takeaways. Okay, so with that, I'll start with the background that builds into the values. So I wanted to start with a map that shows the range of Psiĩ of Manoomin. There are 3 different species on this continent, on Turtle Island, of Zizania. There's Zizania palustris, which is northern wild rice. And you can see that this species is mapped in the purple to yellow color, purple being low density, yellow being high density. We also have Zizania aquatica, which is more southern wild rice, and then Zizania texana, which is a remnant population growing in Texas today. And this population is a remnant of when glaciers used to cover this continent and Manoomin Psiĩ grew farther south. And I think it's so impressive and amazing that Manoomin Psiĩ has lasted for thousands and thousands of years on this continent and survived multiple glaciations and continued to adapt with all of that environmental change. And this is its region that it grows in today. Sadly, it is declining across the region. It's pretty much all gone from what we call today Michigan. And then we've seen about a loss of a third of the Manoomin area in present day Minnesota and Wisconsin since the 1900s. Most of my talk focuses on Zizania palustris, this northern wild rice, but some of it also looks at Zizania aquatica, given that that also grows in the southern regions in Minnesota and Wisconsin. So I just want to show you where it's growing. This, again, high density is yellow, low density is purple, and you can see that it's mostly growing along the coasts. Importantly, Indigenous people also share homelands with Manoomin and Psiĩ. This is a map of the Oceti-Sakowin territory, so the Lakota, Dakota, Nakota people who share and have a connection with Psiĩ. We also have Anishinaabe territory. So Anishinaabe people are the Ojibwe, Odawa, Potawatomi people, and they share an important relationship with Manoomin. And many more Indigenous nations across this continent, across Turtle Island. They have direct relationships with Manoomin Psiĩ, but also enjoy it and respect it through trade. And as we all know, we also share this geography with the settler nation of the United States. So in this map, in the hot pink, so you really see it, we have the land cession treaty boundaries marked. So treaties are nation-to-nation agreements. So these are treaties between the US nation and Indigenous nations that ceded territory from Indigenous nations to the US. And those boundaries are marked on this map in hot pink. You can see that it does not cover the eastern region because those treaties were signed with European nations. And so we're not in this data set. So what I want you to take home from this is that we are in the heart of Psiĩ Manoomin's homelands. I've added to this map the tribal lands of this region as well in purple. You can see a lot of purple throughout this presentation because it's my favorite color. It's clearly also Manoomin Psiĩ's favorite color because the flowers turn purple. So we're in good company. And to share with you the dates and the communities connected to these treaties, This is a map with color coding which nations signed which treaties and in what year. So we have Anishinaabe treaties, up north, and these are the Ojibwe nations, many of whom we work closely with, as well as Dakota nations in purple, and then Ho-Chunk, Menominee, and Sac and Fox as well in this region. And so I want to emphasize this. Hopefully many of you already know this, but tribes are sovereign nations, and this sovereignty is directly connected to land. And this relationship continues today. And you can see that through present day relationships and practices with Psiη and Manoomin. You can also see this through language and culture and knowledge systems that are directly connected to this land. Throughout this talk, I will talk about indigenous knowledge systems and refer to the ecological knowledge, the science, ecological science within that system as traditional ecological knowledge, or TEK. It's an imperfect term, but it's the term that we use on the project with our partners, so that's the term I'll be using. So, as I said before, Manoomin is the cultural foundation and sacred relative for the Ojibwe. It is central to their migration story, the prophecy that guided them here from the St. Lawrence River to the place for food that grows on water. And you can see that when it grows in abundance, as it does on the Fond du Lac Reservation, it blankets a whole lake. It really embodies abundance. I've never been around something so abundant when it is very healthy. You can see other photos of different processing and life stages on this slide, as well as a historic photo of an old practice of bundling rice to mark out family rice beds, but also to protect it from wind and from birds eating it. Psiĩ is a sacred food and first medicine for the Dakota. This is a photo of me and Leah out at Prairie Island looking at Psiĩ that was returned to the Prairie Island Indian community. And so this is Zizania aquatica. It's very tall. And you can also see a photo of a drawing of traditional harvesting. And I had the privilege of attending an event this past summer with Leah to enjoy the Psiĩ, and it is returning to several Dakota communities. Ojibwe nations retain the right of harvesting Manoomin on ceded territories, and this is explicitly stated in treaties. And so this is important. Also, under our understanding of treaties, nations do not cede anything they don't explicitly say. So it should be that all tribal nations retain the right, any right that they did not cede, since they were sovereign nations prior to the US coming here. So indigenous nations should also, that do not have these explicit rights, also should retain the rights of gathering outside of the reservations on ceded territories. Lastly, I want to name and take a moment to recognize that the University of Minnesota has contributed to and benefited from indigenous land dispossession. It's contributed to and benefited from habitat destruction of Manoomin Psiĩ, as well as led wild rice cultivation and genetics research that has been done without full tribal consultation. There's a lot to say here and to know here, and a lot of my work has focused here. So I'm giving you a couple more resources. But this is important in grounding the values and the way we approach the work. I also want to acknowledge the gift that this department in the University of Minnesota has given me by saying yes to allowing me to do this dissertation and to be up here and tell you these things. And I am hopeful that we can continue to learn these hard truths and be better and work towards justice and healing. So my research approach, to summarize, is grounded in values. And from those values, we enact community practices. And then from those community practices, we can collaborate, come up with questions together, hypotheses, and then we choose respectful methods and then employ those methods within the logics of the worldview that those methods come from, so fully rigorous within Western science or mainstream science, and then take the results back to the collaboration to make sense of them, understand them, figure out what the limitations are, what does this mean? And that's an iterative process. And so to guide my work, I'm drawing directly from Dr. Robin Wall-Kimmerer and her description of bringing Western mainstream science with TEK, traditional ecological knowledge, She uses the metaphor of the Three Sisters garden, where corn is TEK. It is the strong leader. It is the intellectual scaffold that grounds and guides this work. Western science, mainstream science, are the beans. They have really powerful qualities such as nitrogen fixation, and they do produce really nutritious foods, but they're spindly and need that direction and guidance from TEK. And then the squash shades out the garden and creates a safe space for collaboration. And I see that as our values and community practices. So from these backgrounds, our values include humility, reciprocity, personal connection, interrelatedness, spirit, and healing. We put those values into practice through many different community practices, some of which are named here. And here are some photos of many of those in action. I want to highlight one in particular because it's really important. That is that we have official memorandum of understanding between tribal nations and university researchers to hold university researchers accountable for respecting tribal sovereignty, because this has in the past not been respected, and a lot of the ways research works really centers academic privileges over tribal nations. I don't have time to go into this, but I could talk about this for a long time. But one important piece is respecting tribal sovereignty around data ownership. And so from these values enacted through community practices to build relationships, we've been able to build the Gidaa-naanaagadawendaamin Manoomin Research Collaborative, which translates from Ojibwe to first we must consider Manoomin, the wild rice. And we've had the privilege of working at many different Manoomin waters across the region. They're all mapped out here to do in-depth site-specific studies with our partners. And so from these relationships, we've been able to share ways of knowing and better understand each other. And the way that we actually have been able to do this is through a lot of work. And I'm going to walk you through the steps that kind of follow the seasons. That's why I have Manoomin in the center here. So first, we've been able to go out in the field together. This is really important. We get to paddle together, be out on the water. We're deploying sensors, as well as collecting geochemical samples, as well as sharing stories, listening to Manoomin, and sharing food afterwards, and taking extensive field notes. And then we come back to the lab and process that data as grad students. I did a lot of processing of water level data, creating some preliminary analyses, graphs, and such, and then compiling them into reports. And these reports compile all of that quantitative data, as well as the qualitative notes that we've had throughout the season of all the stories that have been shared. And we share these back with our tribal partners, one report for each of the lakes that we work at, and discuss. Most of these meetings, I think all of them have been over Zoom, because a lot of this happened during the pandemic, to really discuss what did the results mean? What does it spark for you? What questions? What happened over the summer? And bringing in all of our knowledge together and putting it on the table and seeing what we can make sense of. And from all of this collaboration and conversation, we have shifted on the Western science side how we see Manoomin sing. And you can see this transformation of thinking through the conceptual models we have made throughout this project, many of which are pictured here. And from all of this shifting of knowledge, we come up with new questions, new approaches, and new ways to go about doing fieldwork and begin the cycle again. And this process has fundamentally changed how we see Manoomin. We started as the biophysical researchers really thinking about sulfate and how sulfate contaminates Manoomin and harms Manoomin. I'm going to walk you through how our thinking has changed. And a lot of things will be added to the slide, so it's okay that you cannot see that. I know that you cannot see that very well. So we started with an interest in sulfate, but heard from tribal partners that actually they had a lot of other questions. There are a lot of other habitat requirements that Manoomin needed. One we heard about was the importance of cold winters. Cold winters often related to better Manoomin that following year. Seed bank availability was important, as well as nutrient availability. Manoomin needed space to grow from other plants. It needs shallow, early season water levels for that floating leaf stage, as well as stable growing season water levels for that floating leaf stage. Pollination is also important, is wind pollinated. It's also susceptible to herbivory, disease, and removal by humans. And also late season storms can knock over plants and also knock off the rice and make it hard to harvest. So that's a lot more than sulfate we were thinking about, and we kept hearing more. We learned about how other climate factors were impacting sediment and sediment mixing, as well as other animals. We learned about muskrat, carp, red-winged blackbird, rice worms, and all of these relationships continued to grow, and our ways of thinking about this continued to change. We also heard a lot about climate change. And this is a snapshot from the GLFWC, the Great Lakes Indian Fish and Wildlife Commission vulnerability assessment of Manoomin. And more recently, we've heard a lot about land use change and this understanding of how the last 200 plus years of European American colonization and land use change has impacted Manoomin Psiį. We've especially heard this from our Dakota partners about how agriculture and the loss of prairies and that extensive land use change has impacted Psiĩ. And we've also been working with social scientists, and our tribal partners have also reminded us that humans are not just a negative force on Manoomin. There's also a lot of positive ways that people can impact Manoomin through restoration, through harvesting, through reseeding, and even starting to see our own research collaboration as part of this. And so at this point, this was several years, and I even added some, creating the slide, of adding lines and drawing lines and sharing it back with people and getting feedback and adding more connections. I was very proud of my lines, very into them, as you can see. And I've redrawn them many times if you followed all the iterations of this, and I redrew them for this presentation. So I'm still proud of my lines. But one of the times I shared this with our group, a tribal member, Melanie Montano, told me, you know, this is great, Maddy, but it's not grounded in an Ojibwe worldview. And that puzzled me, because I was like, one of the things I've heard over and over again was the fundamental importance of interconnection within an Indigenous worldview. And I was showing it. Everything is interconnected. And so I was like, oh, what am I missing? And she connected me with Psiĩ, who has led work in creating another conceptual model grounded in an Ojibwe worldview using the Ojibwe medicine wheel. We start in the east with spring. It's also the place of infancy, of infants. We move to the south for summer, south and youth, and then west, move to the fall, at the stage of adulthood, and then winter is the northern direction. That's also associated with elders. And so from this medicine wheel, Psiĩ created this model, which has also grown over time. So this wasn't the first draft he showed me, but it was pretty close. So in the eastern direction, we have Manoomin Ake, human harvesters, he or she or they who harvest rice. And people are in the eastern direction because we are the infants. We know we have things to offer, but we have a lot to learn from all the other directions. In the southern direction, we have Gidaa-naanaagadawendaamin. Apologize for my rough Ojibwe, but it translates to all our relations. So thinking about our animals and plant relatives. In the west, we have Aki, earth, land, ground. We're also thinking about water, Nyblade, and the climate. And then in the northern direction, we have Manoomin itself. Manoomin is the elder in this work. It knows what it needs. And all of these directions are important in supporting Manoomin's Minobabadaziwin, which is in the center, Manoomin's good life. And so when Psiĩ first showed this to me, I was thinking about telling this story on my run, and I realized, I think the very first thought I had was, this is way too simple. How could this be the model? And luckily I was smart enough not to say that out loud and just keep that thought to myself and use that to deepen my self-reflection of like, why was that my first thought? Knowing that I'm coming from a Western worldview. And I was like, where are all the lines? I worked so hard on all of those lines. And I realized as I started to sit with it, you know, I was really into those lines because I'm coming from a Western worldview where we often need a reminder that everything is interconnected. And so I was going to remind you and remind myself that everything is fundamentally interconnected. But that is already baked into the Ojibwe worldview and understood. And so you don't necessarily need to draw out all of those lines because everything is understood as interconnected. And so now when I look at this, it is simple, but not simple in the way that I mean basic or unsophisticated, but simple as in elegant, the elegance of thousands of generations of knowledge that has been built from deep connection with this ecological community and distilled to an essence of what is really important. And I was thinking about how it's kind of like when you boil sap down from maple syrup. And then I was thinking, Fond du Lac elder also shared with us when we shared this with him, he was like, oh, it's even more simple. Well, he didn't say simple, but it's even more simple. It comes down to gratitude. So there's more ways to see this. And maybe gratitude is like once you boiled maple sugar down into, or maple syrup down into the sugar, the real essence of it. But I've really come to respect this model. And I see it now as possibly the front side of embroidery that is elegant and calm and culturally approachable, easier to wrap your head around, possibly. And my model as the back of embroidery. And it's beautiful and important and the truth, and really important for those of us who need a reminder that everything is interconnected, and it's a different way of seeing. And so I've come to see my work in Western science as a slice of the medicine wheel model. And now you might be thinking, wow, it's 26 minutes into the presentation and she hasn't even said any research questions. And that is okay, that is intentional, because there is a lot of relational work that comes before you can ask questions that center tribal priorities. And I wanted to name and show you that work and invite you into it, as well as acknowledge that that is the work that I did and uplift that. So from all of that work, these are my research questions. First, we look towards the north and ask, how is Manoomin doing in this region? Then we're looking to the west to think about climate and land cover change impacts on Manoomin Psiing. And then we're thinking about tribal harvesters and what are the impacts on tribal harvesters. The fourth question is, how can we take care of Manoomin Psiing? This question I answer using case studies, and this is a different approach. The other three I'll answer and look at using statistics. So I ask you just to table that question and I'll come back to it at the very end as we talk through it. But for now, I'm going to focus on the first three. So our first hypothesis is that there is a significant decline of Manoomin abundance across the region, but this is complicated by natural abundance cycles and local relationships. And this is directly informed by observations from our tribal partners of this decline, of the importance of local relationships. There's a lot of skepticism of what can statistics tell you. The local relationships are so important because the history matters on what's happening at each water body. And we also know from TEK the importance and the natural presence of multi-year cycles, about 4 years of high Manoomin abundance, low Manoomin Psiing abundance, and then some middle years. The second hypothesis is related to the second question with regards to climate. Since we heard about the importance of winters, we hypothesize that we'll see more Manoomin abundance with more snow, lower winter mean temperatures, and greater ice duration. We also, as I mentioned before, heard a lot about the importance of water levels during that floating leaf stage. So with lower water levels during that floating leaf stage, we hypothesize more Manoomin, and also related, less precipitation during that time. And lastly, we hypothesize that with more days above 4 degrees Celsius, or what I will refer to later as growing degree days, the more Manoomin. And this is coming from Western ecological science, that when we have more warmer days, we have more days for plants to grow and there'll be more of them. The second part of this hypothesis is regarding land use, land cover, and this work has been done in collaboration from hard work by Gracelyn McClure. I want to acknowledge that. And so we hypothesize that with less development, less agricultural area, and more evergreen forests in the watershed, we would see greater Manoomin abundance. And this is from direct observation about the impacts of urban area and agricultural area, as well as the known hydrologic changes that those land cover types cause. as well as TEK talking about the importance of evergreen forests and the loss of those with ever since deforestation and logging of old growth forests, as well as climate and other management changes such as fire suppression. And lastly, the third hypothesis is that we'll see greater tribal harvest with increased Manoomin abundance. And this is pretty straightforward, but we have tribal harvest data, and so I wanted to see what the relationship is within the data. So to answer these questions, I pulled together tribal, state, and federal data from across the region. Manoomin is complicated, and there's a lot of relationships, as I've shown. And so my goal was to pull together as much data as possible to see different angles and different snapshots of Manoomin so that I could come up and better understand what we could learn about Manoomin through these quantitative statistical methodologies. And so I have some of the data here. It's presence-absence data of Manoomin, density surveys, harvesting reports, pounds harvested, as well as narrative case studies. And that's what I'm going to use to answer that fourth question that I alluded to. And those case studies come from our work directly on lakes. And then I'm pulling together land cover data, climate data, and ice cover data. And I want to take a moment to emphasize that tribes and tribal nations and intertribal organizations have been doing an immense amount of work monitoring Manoomin Psiį for decades. They've been going out to do plot level surveys at 20 plus different sites across many different lakes, as well as aerial surveys. The 1854 Treaty Authority has been doing this on 10 lakes since 1998, and the Great Lakes Indian Fish and Wildlife Commission has been doing this on about 40 lakes since 1985. And this is to inform their protection of Manoomin and also to inform rice chiefs about how they want to host different harvests. And so it's a very incredible way that TEK has informed monitoring because they're focused on an important being. They're focused on lakes that are really important for harvesting. And in some cases, they're not privileging the precision that Western mainstream science really loves, and instead coming up with methods where they can survey a lot of lakes over a long period of time to give us this whole picture, or better give us a whole picture. And so I've been really lucky to use this data. So we can jump into the results. First, this is a graph showing all of the data from the 1854 Treaty Authority. So this is the Arrowhead region or northeastern Minnesota, but from Fond du Lac Reservation, and then the Great Lakes Indian Fish and Wildlife Commission. And they survey lakes in northern Wisconsin, in 1837, I think also 1842 ceded territories. So on the x-axis, we have year. On the y-axis, we have the total number of Manoomin stocks. Each color in this graph is a different water body, and they're all stacked on top, all added on top of each other. And so some of the things you can see from these graphs is that there is a total decline across the region, and there's also a lot of variability. As I said, TEK teaches us that there is natural cycles within Manoomin. And in fact, when I do time series analysis of these data sets, we can see that there's a statistically significant multi-year cycle on 2/3 of these water bodies. The average or the most common length of that cycle is 3 years, so pretty much aligning with TEK. I also used statistical models to look at the overall trend through time. And we see that density on off-reservation lakes available for tribal harvest has declined over the last several decades. So the top two graphs are both density surveys. The left one with the orange line is the Great Lakes Indian Fish and Wildlife Commission. The other one is the 1854 Treaty Authority data. The colorful strong line in the middle is the model result. The gray lines are the data, the actual surveys. The x-axis is year, and then the y-axis is density. And so we can see that there is a decline that's statistically significant across both data sets, and it's about 6 to 7% decline per year. And that is on top of and accounting for all of that variability that we know is part of this system. Using the Glyphwick harvester surveys, we can also look at harvesting trends through time. There is a declining rate of return on harvesting surveys. So instead of looking at total pounds harvested, I looked at pounds per trip. Also, there's a lot that affects harvesting beyond just whether or not Manoomin is there. For example, this is my 5th year harvesting, and the first 4 did not get very much, and very little to do with the actual Manoomin and more to do with my own personal skill. But this year I got better, and also the Manoomin was in abundance, thanks to the teachings of Joe Gravine helping me learn how to harvest. So tribal knowledge and passing on knowledge is an important piece of this, as well as many other factors that affect harvest. But we can see that there is a decline of 3% per year for tribal harvest, and there's no statistically significant decline for non-tribal harvest. So looking at climate, we see that there is a significant relationship between precipitation, water levels, and Manoomin density. Now, I know there's a lot of graphs on this page, so I'll walk you through how to look at them. On the top row is the GlyphWick data, and the bottom 2 rows are the 1854 Treaty Authority data. The columns are based on the life stages of Manoomin. So the leftmost column is the submerged stage. The second to the left is this one here, is the floating leaf stage, and then the flowering stage, and then the dormant stage over the winter. On the x-axis, we have the variable that I was testing. So here it's precipitation for the first 2, and then the bottom one is water level, because the 1854 Treaty Authority also measured water level, which is insane and awesome, because that's a lot of work. And then on the x-axis, we have Manoomin density. So it's how these variables that I'm testing relate to Manoomin density. And the darkness of the color shows you how strong of a relationship. And the gray is the confidence intervals. So the first thing that jumps out is that during that floating leaf time, these 3 graphs, there is a consistent negative relationship between precipitation, water level, and Manoomin density. So higher precipitation relating to higher water levels impacts Manoomin negatively. With the submerged stage, we have differing results. It goes down at first and then up to this positive relationship, but also a wide confidence interval. But it's just curious why that's different during the submerged stage. There is very little significance during this flowering stage. So the water levels and precipitation don't have a strong correlation with Manoomin density. We do see a positive relationship between snow and Manoomin density the following season. It's not super significant, but they're both consistently positive. I also looked at temperature and ice related to Manoomin density. So again, the top is the Great Lakes Indian Fish and Wildlife Commission data. The bottom one is 1854 Treaty Authority. This first column is growing degree days. So we see with more days above 4 degrees Celsius, we have less Manoomin, which is actually not what we thought would happen. And it's most significant in GlyphWick data. For winter temperatures, this middle column, we see that they're both a negative relationship. So warmer winters, less Manoomin, and it's most significant for the 1854 Treaty Authority data. And then with the GlyphWick data, we also had enough data to do analysis on ice duration. And we see with longer ice duration, we have positive impacts on Manoomin. So to summarize this and put this into context with anthropogenic climate change, we see that in the future, there will be less snow, higher winter mean temperatures, less ice duration, more precipitation during the floating leaf stage, which relates to higher water levels, and more days above 4 degrees Celsius. And so if you could follow all those graphs, you can see that the climate change is moving in the opposite direction that supports Manoomin health. And this is where I draw the conclusion that anthropogenic climate change harms Manoomin. I also looked at land cover. And so I looked at a lot of different data sets. Each data set is a different column. The y-axis is the likelihood of Manoomin presence. So these are presence absence data sets. And then the x-axis is the percent coverage in a watershed. And then each of these columns are different land cover types. We can see that for the Druze data in gray here, crop area, pasture are not super significant, but there is an interesting positive relationship with urban area, which is not what we expected at all. And so that raises a lot of questions. And there are some things that are different about that data set that might explain that, but we're still thinking about that one. With the Mirbo data, we see a consistent negative relationship with all of these land cover types, especially crop area and urban area. And then with the USGS data, we also see a negative relationship with crop and pasture area and urban area. I also looked at the number of dams in relation to Manoomin presence absence, and that was statistically significant for the Druze data, so more dams here, with the x-axis being dams, less likelihood of presence. It's also negative for the Mirbo data, but there's a large error as well. And then alter streams, we also had data for the Mirbo that data set, and you can see that there's a negative impact of altered streams, but again, lots of error, not super significant. And lastly, I looked at forest type, and for the sake of time, I'm going to zoom in on the results that were most significant. There are a lot of data that didn't have strong significance, but with the 1854 and Fond du Lac data combined, we do see a positive relationship between evergreen forests and Manoomin abundance. And so how does this relate to European American settlement and land cover change that resulted? Well, if we look at modeled data for land cover in the 1800s, which you can see up here for the ceded territories compared to 2020, you can see a significant loss in grasslands and forest area, conversion to urban crop and pasture land. We see a total for this whole area of 5,710 dams. And the forests that remain are not the same forests that were here, since there was massive deforestation. We see a loss of evergreen stands and also change in that structure with fire suppression. And so these land use changes are the result of settler colonization, and they have had a negative impact, likely had a negative impact on Manoomin directly, and we know that through observation, but also this data supports that this general change has caused harm. And I said in the very beginning that Manoomin is really good at adapting, and it survived many glaciations, and it has this impressive skill. But this change from 1800 to 2020 is happening about 100 times faster than the biome change following the last glaciation. So it's likely that this change is outpacing Manoomin's ability to adapt. We see, and so then to draw this back to tribal harvesters, we see that the x-axis here is stock density, the y-axis is harvest. So with increasing stock density, we have increasing harvest, but it does start to decline at the end, which could be many reasons, but one of which is harder to harvest when it's very, very dense rice, which I've also struggled with personally. So to wrap up those three questions and that work, we can see that Manoomin Psiį available for harvest is declining across the region, in part related to land cover and climate change. Climate change will continue to negatively impact Manoomin density, and this decrease in density results and relates to less pounds harvested by tribal members. But humans do not just have a negative impact on Manoomin, and this is important to remember. And we can even see this in the data. There's actually a positive relationship between previous harvest and present harvest. So this graph shows average pounds harvested for the past 2 years related to the average pound or the pounds harvested presently, and there is a positive relationship. So harvesting may directly impact and help Manoomin when done in a good way, but it's also true that harvesting builds and deepens people's connections and relations to Manoomin that might encourage more caretaking. And this is where I want to share and uplift the work of tribal resource managers who've been working across the region to take care of Manoomin. And this and all of the work that people have been doing may also be why there's such large errors on some of those land cover changes that we thought would be such a negative impact, because people are working to take care of Manoomin on the ground. At Spur Lake, there are folks reseeding and removing vegetation in different plots. You can see up in this picture. At Clam Lake, folks have removed carp that were harming Manoomin. Psiĩ is returning to different Dakota communities through different restoration work that's happened on the Mississippi and reseeding. Ogeechee Lake on the Mille Lacs lands, they lowered the water levels by lowering dams, and this brought back Manoomin. And they're also working to lower water levels on Swamp Lake by removing vegetation from the outlet. And so through all of these caretaking strategies and all of the case studies, we've seen so many different ways that we as people can support Manoomin health. Through tribal management and collaboration with tribal nations to really understand the local connections and history. Harvesting possibly can help, reseeding, bundling rice, water level control, clearing outlets, beaver management, vegetation removal, sediment mixing, geese exclosures, forestry practices, agricultural practices, pollution prevention, all to work to protect what is left. And so I really just want to honor and celebrate the work of so many people around the region who've been doing this. And when we've been able to share and celebrate this is through sharing, such as this moment today, but also through other gatherings such as the Manoomin Psiing Knowledge Symposium, and through sharing at conferences. And so to wrap this up with my reflections, I wanted to share a quote by Joe Gravine that we shared at a conference last fall that says, "We are healing the environmental wound where Western philosophies have dominated it and caused destruction. We are healing by bringing Indigenous knowledges up to equal so we can achieve environmental justice for Manoomin." And so these are the takeaways I wanted to share with you, because these are the things that I'm taking away from my own work and working on this for 4.5 years. And that is first, that there is a regional decline of Manoomin on ceded territories, and it's about 6 to 7% per year. And this is caused in part from climate and land cover change. And this reduces off-reservation harvest by Indigenous people, which is a right guaranteed by treaties. And we as humans can restore and care for Manoomin Psiing as Indigenous nations have always done. And I am referencing Leanne Simpson's book, As We've Always Done, there, because it's an amazing book. So with those concluding thoughts, I would like to acknowledge all of the people who have supported me. Alex, a former grad student on this project, was really good at these closing acknowledgement slides where he had everybody that was important. And I was just like, no way I could do that, because there's so many important people that have helped me get here. So I put a lot of you on there. I want to say thank you to the tribal collaborators, the partners who've grown into my inspiration for this work. They've become my mentors and my good friends. I want to thank my advisors for allowing me to do this work and guiding me in creating the space and community where this work is possible. And for my lab group for taking me up on collaging. For the whole entire research collaborative, Gidaa-naanaagadawendaamin, Manoomin, and for my friends and family. And so with that, I say miigwech. Thank you. And yeah, so now we invite questions. Kaylee said that Zoom folks, you should be able to unmute and ask, but you can also type them in the chat. And also, we'll start with folks in the room though. So does anyone have any questions? Oh, maybe, yeah, Shanti.
I have a question. What do you see as like your next steps going forward, like with this work, or do you have like things you're thinking of doing as you move on to your next adventure here?
Yeah, I really want to publish this work. That's like the immediate thing. And I think that's making Crystal laugh. Like part of having a job and a deadline was like, oh, I'm gonna finish all of the whole dissertation before I wrap up the other paper. So I have I really want to get it out and share it via publication. That's the first step, because right now it's in dissertation form. Yeah, my goal, there's a lot of environmental data out there. And one of the teachings within Indigenous knowledge systems, I think it's in braiding sweetgrass as well, take only what you need. And I've been doing a lot of field work, and we can go collect more data, and that's awesome and important, but also thinking about how can we use what's already been taken and collected and take only what we need in terms of even data collection to hopefully inform more strategic actually field monitoring. But so I'm really interested in continuing to work with tribal nations to analyze data to answer their questions and also support more monitoring where they see fit. And in New York, I hope to also build relationships with the Haudenosaunee nations and do that work. But I'm also really open because I know I'm there to learn a lot because I don't know as much about that area and those people. So there's some of where I'm going. I probably will go like nap first, but yeah, and then we'll go out on Zoom. Yeah.
On slides 58 and 59,
yeah,
and some of your graphs, you had some little asterisks.
Yeah.
What were those for?
Yeah, those are this.
Want to just quickly repeat the question? People on Zoom might not be able to hear.
I think Haley said that they would, but I'll repeat them. So the asterisks on some of the graphs was, I guess that just explains the question, but those are indicating significant values for p-values. I was running short on time and didn't do as good a job explaining every little thing, but that's, yeah, to show different levels of significance. Francesca?
Yeah, I just had a question. Is it true you're slightly allergic to wild rice? Someone told me that.
Somebody who went ricing with me. Yeah, I mean, I think it makes a lot of people itchy, but I get like very sneezy in the field. And maybe it's not because of Manoomin itself, it's like other beings out there, but yeah, it sounds like I have a cold by the end of the day.
I just wanted to share how truly dedicated you are there.
Yeah, I'm not allergic to eating it, but I'm allergic, like my skin is allergic to most things. Yeah.
In one of the early photos, you showed like the historical photo of bundling of the wild rice, and you talked about how families would bundle the stalks, or and could you talk more about how it's harvested in the past and today, like the significance of the bundling?
Yeah. I think that bundling is really interesting and I'm still learning a lot about it. I can share what I know, but I'm not an expert by any means. So it is a traditional practice that started to peter out in the 30s, I think. And it takes a lot of knowledge to know when to do it and how to do it in a way that's not going to hurt the plant. But sometimes it was used to mark out which beds were which families, I think sometimes with elders who couldn't get out as quickly. It was used, and then some folks are starting to use it now, or try it out again. And this is where I don't know as much, but thinking about if late season storms are an issue with climate change, how might bundling actually protect them? But it's incredibly time consuming and requires a lot of knowledge. So there's a lot of challenges with it too, but it's interesting to think about how past practices might be used today. And learning from that as we face climate change. But I think I think Steve Smith probably knows way more about all this than me, but and other folks on Zoom, but like you harvest with a canoe and knocking sticks and a push pole, and that's been happening that way for a very long time. So that's the same process. I think there's more mechanized ways to process after you've harvested. With more machines and stuff, but there's also folks who still do the traditional processing, but that's a lot of work too. It's intimidating an audience where I'm like, oh, there's so many people who know way more about Manoomin than me.
Maddy, I'm kind of curious about how much you can distinguish in your data between Zizania palustris and Zizania aquatica for a lot of your trends, because I'm going to guess, but you can speak to this, that most of your data is on Zizania palustris. And have you distinguished Zizania aquatica and seen differences, for example, maybe in winter trends or other things, since it does grow further south? Mm-hmm. Have you been able to do that, or is that something that you think can be done? with the data that you have or other data?
The data that I was using doesn't differentiate, and I think that's because it's mostly Zizania palustris. And I know folks at Glyphic have found some Zizania aquatica on their lakes this past couple of years. So I think there's potential for that in the future, but that's not the current level of the data set now. But that's an interesting question, thinking of how these species are going to move and change with climate change and what benefits they each have.
Yeah, I mean, as a kind of a follow-up question, does anyone know if is there evidence that Zizania aquatica has migrated north at all? Like, is it capable of migrating? I'm just like thinking about your work with climate change and what the future kind of holds for
yeah, I know there was a lot of efforts to grow Zizania aquatica up in Saskatchewan in like the 70s and 80s as part of, like, they were actively trying to find places to grow it. So there's that work, and that's a whole complicated history, but I don't know specifically how it's been moving with climate change. Yeah.
So kind of relating to some later slides about some of the like land management practice work that's done to try to mitigate some of these impacts. Is there any discussion about like ways you can implement like sort of engineering solutions that don't kind of overstep boundaries and damage traditional practices? And like what does that kind of look like moving forward?
Mm-hmm. I don't know if I have a good answer to your question, but what it does make me think about was one thing that I didn't really include on the slide, which is the importance of variability. And this also, I think, relates to something Joe said at the conference earlier this week. But I think it's so cool that each tribal nation and resource managers are trying different things. And some folks find some mechanisms, such as going in and taking out competitive vegetation, as too intrusive and not respectful of those beings. And then others are doing that and trying that. And also with water level management. And so there's all of these different tactics being tried and all of this experimentation that's happening. And people have different opinions about different management strategies and what's respectful and what's not. But that also creates this space of lots of different conditions for Manoomin to continue to grow, which hopefully will increase its genetic diversity and which does improve its resilience. So I think that experimentation and that variation is really important. And it relates to what Joe said earlier, because he was calling for more experimentation in the face of climate change as something that we need. Does that answer? Okay. Do we have any questions on Zoom? Oh. What was your role of self-reflection in your research process? Self-reflection has been a part of so much of my life, constantly journaling and reflecting. And I think a big piece of it was initially during coursework too, and really being exposed to a lot of Indigenous scientists and scholars and doing that self-reflection and then learning in the field with folks and connecting what I was reading with what I was learning. And I think my community, both students, researchers, staff, faculty, sharing and talking and growing those reflections with the community has been super impactful and important to challenge me to continue to learn and grow. And then we've been able to take that to the university and the department and challenge these places to respect tribal sovereignty, to really understand the history and move forward and try to move forward in a better way. So I'm having a hard time answering, I think, because it was so part of every step and has influenced the reflection within myself and where I want to go, and also the reflection I've had with this community. And I think I entered science and math, and I've told some of you this story before. I have been good at math when I was a kid, and so I thought that was what I was supposed to do because everybody in my life valued math and science. And that's what I thought I had to offer the world. And I had this relational side of me that was to the side and wasn't as important as the math and science. And it's through this work and through teachers that I've been able to see the value of both and bring my whole self to the work. And that has been a large process of self-reflection And I'm just so grateful that I got this opportunity and hope that through my work with students in the future, through my work here with all of you, that it opens more space for more of you to bring all of that to the table, because math and science are important, but they're just one slice, to quote the slides, of that medicine wheel. So I'm having trouble keeping track of everything. I don't think so. I apologize if I missed one.
I think as more gratitude, this was together from another collaborative, and many people have.
Oh, thank you. Right, open it. Oh, thank you. Oh, thank you. I'll have to share it with folks on Zoom.
And if there are
But
people in the room who didn't get a chance to sign it, who would like to sign it? Do that. So, thank you so much, Maddy. Everyone other than the committee members or who the one or Friday afternoon?
I gave up that optimism.